Okay, folks, so we're at the point right now we have finished up 5.6, and we're going to have time to go over questions you got on 5.6. We'll have time tomorrow and Thursday, and then Thursday I'll give you the take-home tests over your break then. Make sure right now we're going to do another example that deals with law of sines. We're going to do some kind of extended law of sines, cosines, and area questions. And we're going to do an example, and to do this example, I'm going to share a picture with you from an old textbook, so make sure that your iPads are on and signed into the web filter, because I'm going to share a picture with you, and we will then open that picture up in Notability and be able to then go through the problem that we need to. And then I'll get you the worksheet as well. This worksheet that I give you today is going to be due after break as well. I'll give you the Memorial Day weekend for that as well. So I've got to turn my AirPlay on. All right, so I'm going to cross my fingers. So swipe your control panel up on the bottom and make sure that your AirDrop is on and available from everyone. Okay, so AirDrop, everyone on the bottom. Okay, so I'm going to go into, not camera, I need to go into the pictures. Oh, it went upside down? Alright. Let me just edit it first, and then we'll send the edited version. Which one will do the rotate for me? Alright, so I'm going to AirDrop. To Bridget, to Dawson, to Jared, to Parker, to Kay, to Rebecca, to Shelby, to Will, to Anna, to Cheyenne. Is there anybody I did not get? Okay. Did you guys get the message from me? Get anything yet? You signed into the web filter? All right, for now you're going to have to follow on with somebody else's, and then we'll just, when we're done, we'll send it to you. But for right now, you're going to have to look onto somebody else's. I don't want to sit here too long with them. Okay, so when you receive that, you are going to want to open this in Notability. Now, where are we? Yeah, we're going to have to bring it into Notability, right? So into Notability, and we're going to create a new note. And is it the plus? Photo. All right, so then we're going to boom this up. All right, so what this says then is very often a plot of land is taxed according to its area, and we're going to see a couple of these for homework on our worksheet. Sketch the plot of land described. Okay, so even though we've got the sketch down here, on our homework we're not. So we are going to sketch this. We're just going to refer to what they have here. So sketch the plot of land described and find its area. So from a granite post, proceed 195 feet east along this road. So tell me, please, where is the granite post? What do they have that marked as? P. And then we're traveling how far? Directly east. 195 feet east. So what we would have needed to do here, folks, is holy cow, this is not reacting at all for me. Okay, so we would have started with some point over here. And then we would have gone directly east. And we would have measured that off at 195 feet. Okay, so keep reading. It says, then along a bearing. How are bearings measured? Clockwise from due north. So what I should do now right then is I should put a little crosshair right there, which is going to help me determine that. So they said, then along a bearing of south 32 degrees east. So south 32 degrees into the eastern direction. So south 32 east would put me off. So here's south, and I'm going to come in 32 degrees. And then I'm going to travel for, what does it say, 260 feet? So longer than what my original one was. So 260 feet, and right inside there is 32 degrees. 32 degrees inside of there. Please don't mess up. Page, Austin, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're good. Good. Okay. So everybody good with where we're at? Okay. Keep reading. Then, along a bearing of south 68 degrees west for 385 feet. So south 68 degrees west. So again, right here at this point, I am going to make a vertical and a horizontal. And I'm south 68 degrees into the western hemisphere. So I want 68 degrees over into there. That is 68 degrees. Okay. And then we're traveling, what was it, 385 or something like that? $385. Okay. And finally, along a line back to the granite posts. Okay, so now we're going to connect these up. Now, the key thing with these problems, folks, is that we cannot make assumptions. Okay. According to our diagrams, it might look like we have a 90-degree angle, but do we know if we've got a 90-degree angle? No, we've got to actually go through and verify it. Okay. We've actually got to go through and verify it. So I've got this plot of land here. It's four-sided. I need to find the area of it. How am I going to find the area of this, folks? We're going to have to split it into two triangles, right? Does it matter where we split it into two triangles? No. I mean, I could go from here down to here. I could go from here to here. It really doesn't make a difference. But what I should do right away is find everything that I possibly can. Can I figure out what this whole angle is up here? This was due east, right? So this is a horizontal line, right? And I've got 32 degrees down here. Well, what's this one right here? 90, because we've got a horizontal and a vertical right there, right? So there's 90 and 32. What is the measure of this angle right in here? 122. So we've got 122 degrees right there. $122 degrees. Okay, can we figure some other ones out? Well, how about we work right down to here? Can we figure this one out? Okay, folks, we had a 32-degree angle right here. Okay, right here was a 32-degree angle. So where else is there a 32-degree angle? Inside or outside down here? Outside, right? Why? Alternate interior angle. So that's 32 right there. So if I know that that outside part's 32, then what would this inside part right here be? 58, right? That would be 58. And then what's the difference, or what's the complement of 68? 22. So 58 and 22, what do I have on the inside? 58 and 22 is 80. I've got an 80-degree angle right here. 80-degree angle right there. Do I know any of the other two, though? I don't. I do not know. Okay. But labeling everything I possibly can is going to be a big help for me. I now know where I definitely want to draw my line. Where do I definitely want to draw the line? From the granite post to the 80 or from the 122 down? I want to draw it from the 122 down. Why? Because if I run this one down here, now be careful with what you said. You said bisect. Bisect means what? Cutting in half. Are we bisecting anything here? Absolutely not. We cannot make that assumption. We are not bisecting anything. We're going to draw a diagonal. Okay, but folks, again, what's the end game here? What are we trying to find? Area. We're trying to find area. Well, what's my area formula? 1/2 AD sine C. I need what? What do I need to find the area? Two sides of the included angle. Well, if I draw this diagonal right here, do I have two sides of the included angle? Yes. So let's draw that one. Okay, so now I have over here triangle 1, and over here I've got triangle 2. And which one do I already have enough to know to find? Thank you. Triangle 1, right? So let's go down, let's find the area of triangle 1. Okay, so area of triangle 1 is going to be equal to 1/2. What are the two sides we know? 260, 385, sine of 80 degrees. Okay, we've got enough to find the area of triangle 1 right now. But what we don't have enough for is to find the area of triangle 2. Okay. Well, let's go up and look at triangle 2 and ask what we know about triangle 2. what do we know about triangle 2? I know one side, right? Okay, I know one side. Would we be able to find any other sides? They shared this side, right? So look back over here to triangle 1. Knowing what I know in triangle 1, would that help me find that third side? I could use what? I could use law of cosines, right? If I use law of cosines over here in triangle 1, I can find that diagonal length, can't I? Straightforward law of cosines. So I would know two sides, but I need the angle in between them. Well, I know the angle in between them is part of what? 122. Well, if I look at triangle 1, could I find what part of triangle 1 has an angle 122? Absolutely I could. I could use either law of sines or law of cosines. We usually stay away from sines because we know it's... But is this one going to be ambiguous? No. I know the whole angle is 122. It can't be obtuse. So could I use law of sines to find that angle without ambiguity? Absolutely I could. So if I know what part of the angle is there, would I then know what's left of it for the other one? Yes. Okay, so what's our plan? We're going to go to triangle 1. We're going to use law of cosines to find our diagonal length. We're then going to use law of cosines or law of sines to find this angle up top. Whatever we get here, we'll subtract off of what? The 122 to find this. And then we will have side, angle, side. Is this a long problem? What's a surveyor do when they go out and find the area of a plot of field? Doing what we're doing exactly right here. Is it a long problem? Yes. Is it something we can't do? This is just basic law of sines and law of cosines. Just basic law of sines and law of cosines. So, let's use our law of cosines to find our diagonal length. So, I'm going to call that D for diagonal. So, let's go down. And I'm going to do all of this work below this area stuff. Because ultimately right here are going to be my two areas and I'm going to add them together. So, let's look at, I don't know how those got there. So we'll get rid of them. And we're going to say that diagonal squared is equal to, what are the two sides we've got again in triangle 1? 260 squared plus 385 squared minus 2 times of 260 and 385 and the cosine of 80 degrees. I thought that automatically moved for you. You do the calculator work for me, please. Okay, so type it in and take the square root of it. I want to know what D is equal to. And folks, are we rounding or truncating? No, we are not, but we are going to do what? We're going to store it so we don't have to type it in again. Okay, we will not do any rounding or truncating on this. Okay, so I need somebody to verify that for Jared. Yes? Okay, so Jared, say it again. 425 point ... And we've stored it. We've stored it. Okay, so I'm going to come... Okay, this is that 451 point... Was that right? 425, I'm sorry. 425.51. What was the next thing we needed to find then? The angle up on top, right? That angle up on top. So let's come back down here. All right. So what is the corresponding side and angle pair that we do have? The diagonal and 80 degrees. So the diagonal over the sine of 80 is going to be equal to, what is the side across from the angle that we want? The 385 over sine of, we're going to call that angle P. Why am I calling it P? Because it's the partial angle. We're trying to find that partial angle up there, so we're going to do that. So, tell me how we would solve for sine P. 385 sine 80 divided by D. 385 sine 80 divided by D. And then you're going to go inverse sine of that value. Second sine, second angle. What did you get for angle P, not rounded? And we've stored it as P. Okay, now that wasn't the angle that we were really concerned with. We want to take that angle and find the difference from 122. So go ahead, 122 minus that value. What was it? Okay, yep. Oh, shoot. 58.99 dot dot dot. And we're going to store that as, let's just be consistent, Q. We'll store it as Q. Now do I have everything I need to find the area of the second one? Yes, we got two sides in the included angle now, right? So, let's do it up. We want 1/2 of, what was the side that we did know? The 195. The other one we have stored as D, and we're going to take the sine of what? We're going to take the sine of Q. All right, I want you to compute those two areas for me. And go ahead and compute them both. And then I'll ask you for triangle 1 and triangle 2 altogether. So for triangle 1, we had 1/2 of 260 times 385 times the sine of an 80. What did you get for the area then of triangle 1? Sound right? Okay, 49289. Right. Why didn't you think it was right? Look at the lengths of the sides of our triangle, folks. We're dealing with a triangle that has a length of 385 feet and 260 feet. We're not talking square footage here. We're talking acres. We're talking acres here, not square footage of land. We're talking acres. Okay? It's fine. They should be big numbers like that. That's what we should be expecting. All right, what did you get for the area of triangle 2? 1/2 of 195 and the diagonal times the sine of Q. What did you get there? 3,500 35,000. $35,559 point. Okay, add them together. and I would like this to the nearest 100 feet, square feet. Nearest 100 square feet. Not hundredth, 100. Nearest 100 square feet. 84,800 square feet. And so notice there I did not put equals. I said it's approximately 84,800 feet. Okay? We don't want to round anywhere up until this point. Again, this is the ultimate answer that we're trying to find here, so we're not going to round previous to that. Okay? But then when we got rounding to the nearest 100 takes away a lot of error for you. Okay? So if you did do some truncating or rounding previously, like you shouldn't, you're still probably going to be all right. Okay? But we'll round these then to the nearest 100 square feet. And I wish I knew the conversion right now for square feet to acres, and we'd convert that into acres. But I don't know that off the top of my head. It would be easy for us to find, but it's not going to take the time to do that now. What's the hardest part of this problem, though, folks? The diagram. The diagram is the hardest part of this. Okay? So if I were you, you're going to get two problems that are very similar to this included on a kind of a graded assignment for 5.5 and 5.6. And again, what are 5.5 and 5.6? Law of sines and law of cosines. So these would be... they're from another pre-calculus book that I had. I can't even remember where I got it from now. But and you're going to have two problems that are like this on here. What I would strongly suggest for you when you get to these two problems is just take a piece of scrap paper and start with a point that's towards the middle somewhere. Because you don't know, are you going to be going to the left or are you going to go to the right? Well, if you start by putting your dot way over here to the left and you need to go to the left, you're kind of screwed. So when you get to these problems, start at a point in the middle of the paper. Okay? And then go whichever direction they tell you to. And at the end of every one of those points, what should you put there? A little crosshair. So you can determine, okay, I'm 32 degrees southwest. So south, 32 degrees into west. Okay? And then go however far you need to. Make another crosshair. So you can see your vertical and your horizontal to base them off of these. But folks, by far, the hardest part of these is drawing your diagram out. Okay? Once you draw your diagram out, like a lot of us are going to like to assume that we have something that we don't. I could have drawn this a little bit further out and made it almost look like... If I would have drawn that a little farther out, it almost would have looked like we would have had a right angle up here. But do we know if we've got a right angle? No. A lot of us will make assumptions that we've got angles that we don't. Okay? If you can't find the angle, you can't assume it. Okay? So don't make any assumptions on these. Okay? And again, was our diagram, did ours really look like theirs? Not perfect, right? Okay, now the question is, could we have drawn... They did, didn't they? Okay, so they did it differently than we did ours, right? Which diagonal did they draw? Yeah, they drew this one. Why did they draw that one? Well, they knew those two sides in that included angle, right? So could they have found the area of this one up here? Yup, and then they found that length with law of cosines. And then they split this angle instead of the other one. Did they do the same thing we did, though? Yes, they did the exact same thing we did, with just two different triangles. Okay, and lo and behold, I bet they got the same value. Okay, so does it matter which diagonal you draw? No, does not matter which diagonal you draw. You're going to get there. Okay, it's just what do I know? Where would it be the easiest case for me to split them up? Okay. But other than that, folks, this is just law of sines, law of cosines, and the area formula. Okay? We just got to be careful with our angles and so on and so forth. Okay? Questions on that, folks? Okay. Let me get this worksheet out to you. Send the extras up. Well, what do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There you go. Send those around. Okay, so as they're coming around you, I'll open it up in mine. I think we can shut this one down now. Absolutely you can. You can absolutely do this on Notability. Okay, so those two problems, like what we just saw, are 16 and 17, these two surveying problems. So 16 says, from a cement marker, proceed 260 meters southwest. What's southwest? Yeah, halfway south and halfway west, so it's 45. Okay? To the river. Then 240 meters south along the river to the bridge. Then 280 meters north 40 degrees east to a sign on the edge of Sycamore Lane. And then finally along Sycamore Lane back to the cement marker. So you'll want to map that out. So you're starting southwest, that's this way. So you obviously don't want to start up here because there's nowhere to go southwest. You want to be over here so you can go southwest. Then south, then north 40 degrees east is almost northeast. It's 5 degrees shy of northeast. Okay, and then back up. Okay. This one says, from the southeast corner of the cemetery on Barnum Road, proceed south 78 degrees west. So we're again going southwest. 250 meters along the southern boundary of the cemetery until a granite post is reached. Then south 15 degrees east. So we're going to go southwest, then southeast. For 180 meters to the Allard Road, then north 78 east along the Allard Road until it meets the Burnham Road, and then north 30 degrees east until we get back to our starting point. Okay, so you're going to have to sketch those out. I do want to see your sketches. I do want to see the sketches. And then you've got to divide it up however you're going to get the two triangles. Use law of sines and law of cosines to figure out whatever you lack in the two triangles, and then find your area. And then these ones up here are just basic law of sines, law of cosines ones. I know that these are kind of hard to see, but if you'll kind of work with me here, you can obviously see the 42 feet over here. But from A to B, that's 53 feet. 53 feet, and your angle is 135 degrees. So darken those up or whatever you need to do on your diagram so you can see them. Obviously they're up here as well, but it's kind of nice to be able to see them in the diagram down here. The Circus High Wire Act is even a little bit tougher, but it says the Circus High Wire Act walks up an approach wire to reach the high wire. The approach wire is 122 feet long and is currently anchored so that the angle it forms with the ground is at a maximum of 35 degrees. A greater approach angle causes the aerialist to slip. Are you going to want to walk up something that's more than a 35-degree grade? No. You don't want to walk anything steeper than that. Okay? They say, however, the aerialists find that there is enough room to anchor the approach wire 30 feet back from where it was. Okay? So what we're looking at here, folks, is my high wire, and you don't need to redraw it. I'm just going to draw it down here. You just need to highlight it. Okay. So here is where it's anchored right now at 35 degrees, being 122 feet long. But the aerialist finds that there's enough room to move the anchor 30 feet back. So I'm going to move it 30 feet back in order to make the angle less severe. When this is done, how much further will they have to walk up the approach wire, and what will the new approach angle be? They want you to find this length that they have to walk and that angle theta. So those are the things that you've got to find. Walks up an approach wire to reach a high wire. The approach wire is 122 feet long and is currently anchored at an angle that forms with the ground at 30. Yep, that's all you need to know, those distances. Yep. Yep, you've got a right angle here. You have what here? A 180 right there. So you need to find this and this on that one. Everybody clear with the diagram? Okay. 28. I think we can all see 28. Is that okay? A 34 feet, a 25-degree angle. Okay. This one, can everybody see this one? 47 feet on the bottom, a 51-degree angle of elevation, but the pole is not straight up and down. It's 7 degrees off. It's 7 degrees off, so can everybody see that one? Okay. And then 29 and 31 you've got to kind of draw out as well. 29, a ranger in fire tower A spots a fire at a direction of 290. How is direction measured? Direction is just like course and bearing. Clockwise from north. Clockwise from north. Okay. 45 miles at a direction of 45 degrees. And again, so these ones are clockwise from north. Clockwise from north.
Prom tickets are now on sale in the library. The last day to purchase tickets is this Thursday, May 21st. The cost is $35 per person or $65 per couple. If you plan on bringing an out-of-district guest, there are permission slips available in the main office. These should be returned ASAP. Attention all senior athletes. If you have played numerous sports seasons over your career, you may qualify for an Ottaway Award at the Spring Sports Reception on June 9th. Seniors must fill out an Ottaway info sheet and return it to Mr. Bleacha by this Thursday, the 21st. Information sheets are available in the main office, PE classes, and Mr. Bleacha's office. Ladies, don't forget to come and check out the prom dresses after school today in the cafeteria. Alyssa will be there until 5. Attention all students, this is just a reminder that there is no school this Friday, May 22nd, and next Monday, May 25th. If you need a bus pass for the end of the day, please need a note from the main office this morning. Following students please report to the office, Michael Frank, James Galetta, Jaden Nelson. The varsity boys team.
Okay, so tomorrow and Thursday are work days. Tomorrow and Thursday are work days. A lot of people have a lot of homeworks to get to me. So tomorrow and Thursday are work days, and then Thursday I will provide you with the take-home tests that will be due Tuesday when we return. Okay. This is also going to be due Tuesday as well. Okay? I don't mean to put it off. Get going on it. So if there's any questions that you've got on these next 2 work days, you've got some. But this and the test will be due Tuesday when we return. Questions? Very good.
The varsity baseball team won last night at Walsh.